Imagine that you're sitting in your old high school math class with your teacher, Mr. Newton. Mr. Newton stands at the board and teaches some new concept. As most math classes go, this one's a bit tricky for the first time you see it. Perhaps you're the student that's taking notes and understanding what Mr. Newton's teaching, or perhaps you're the one that's still trying to figure out what he did way back at step 1. Regardless, at some point near the end of the lesson, one of the students asks the question that's at the back of everyone's mind. How will I actually use this in the real world? Though this question is often used by students who try to argue their way out of work, it raises a good point. Using a classic example, if a person were to hold up a gun and say, "I'll shoot unless you can factor this polynomial equation," luckily for most students, their years of math study will have paid off. But unless they run into such a calculated criminal, how does the understanding the identities of trigonometric functions help them in the real world? Why do we teach this stuff anyways? To answer that question, I decided to do a survey of people and ask how much math they use in their jobs and run some basic statistics on them. In doing this, I not only found the data I was originally looking for, but some rather interesting results. Here's what I found. I asked people to rate how often they used a specific type of math in their jobs, on a scale from 0 to 5, with 5 being every day and 0 meaning not at all. Arithmetic was the most commonly used with an average of 3.08, with fractions pulling up a close second at 2.29. Next, more than a whole point lower, fell Algebra 1, Geometry, and Algebra 2, with scores of 1.19, 0.73, and 0.76 respectively. Trigonometry and Calculus were used the least, with scores of 0.26 and 0.16. Interestingly enough, Statistics scored 0.89, higher than both Algebra 2 and Geometry. This means that 79% of the people I asked used arithmetic every day in their jobs, while 66% used fractions, and so on until calculus, where only 6% of people used it in their daily lives. Again, statistics was still higher than the other higher maths, with 29% of the jobs I surveyed using it. So this must mean that if the percentages are so low, there's no reason why we should be learning math like we are in school, right? Well, not exactly. Keep in mind that usually people who know more math get better jobs, right? To answer that question, I separated my data into 4 groups. High white-collar workers, such as doctors, lawyers, and such. Low white-collar workers, such as secretaries and bank tellers. High blue-collar workers, such as technicians and artisans. And finally, low blue-collar workers, such as laundry workers and gas station workers. Unfortunately, I couldn't find enough high blue-collar workers to make any conclusive results for them. As for the other 3, when I mapped their data, I found something like this. In all the categories, the group that used the most mathematics was, surprise surprise, the high white-collared workers. The low blue-collared workers came close in arithmetic, fractions, and algebra 1, but did almost no math after that. The low white-collars, however, did not even come close. Barely 50% of them used even basic arithmetics on their jobs, and less than 10% used algebra. So even though a student's level of math education may not directly correlate with the level of their job, it can definitely distinguish him or her in the job market. Then, for a bit of fun, I compared the data based on males versus females. The data correlated surprisingly well with this. On average, men reported knowing the maths about 13% better than women. In addition, men reported using mathematics in their jobs about 14% more than women. To top it off, men reported that the fact that I learned this mathematics helps me in my job 19% more often than women. Why is this? Well, there are a couple possible explanations, and none of which have to do with men being smarter than women. Perhaps more men go into these fields because fields requiring a high level of mathematics are traditionally seen as more manly. Or perhaps employers hire more men for the same reason. If anything, it could be that men over-report their scores in an effort to show off their manly mathematic ability, while women tend to underplay. Now, onto the survey itself. Usually in this kind of statistical analysis, both the quality and the quantity of the surveys are particularly important. In terms of quality, this survey was pretty good. Generally, those who I surveyed said that the survey was easy to understand and they were able to complete it within a couple minutes. In addition, the questions were as objective as possible in order to reduce possible bias. In terms of quantity, however, this study was a little bit lacking, if you wanted to use it as a conclusive study, that is. For statistical analysis, as more and more data is taken in, the results become more statistically significant, meaning more representative of the population. As I mentioned before, I couldn't get a large enough sample of high blue-collar workers to make any conclusive statements. On the same note, I got much of my data from 2 local doctors' offices, so that may have swung the data a bit out of favor with the many blue-collar workers in general. Even then, I didn't reach anywhere near the number of people needed in order to be considered statistically significant for workers in Georgia, much less the whole United States. Of course, to do a study of this magnitude would be really far beyond my capabilities right now. However, even if it doesn't make Pew Research standards, this survey works as a model for bigger ones. They do exactly what I did, only on a much larger scale. If we look at just the numbers, they tell us that we could really do without a lot of the numbers, meaning the higher maths. We spend a lot of time and effort trying to drill things into students' heads that they will likely never use again. Isn't there a more efficient way to do this? However, there's more to this than numbers. While I was handing out the surveys, many participants said how much they enjoyed taking their survey and remembering their old math classes. A few people told me that even though they didn't use the specific math on their job, they did recognize that the fact that they learned that math greatly improved their ability to work in their job and their life outside of the workplace. One lady even wrote me a note on her thing telling me not to get rid of geometry, even though she said that she never used it on her job. So, could we pull back a little on the higher maths and spend a little bit more time teaching practical applications such as balancing textbook and paying taxes? Probably. Should we completely pull back on them and any effort to learn any maths past arithmetic? Well, only if you just look at the numbers.